Electromagnetic radiation is the basis for all remote sensing. So we're going to take a quick look at some of its characteristics. Radiation moves in the form of a wave. So some of its characteristics are the same as that we can think of for other waves. The first one is the direction of propagation, which is simply the direction in which the radiation is moving. So we can draw this as an arrow here. In most remote sensing, this is either the direction from the sun down to Earth or from Earth back up to the sensor. Another characteristic that we can think of is the wavelength, which is the physical distance from one wave peak to the next. In remote sensing, we use waves that come in a wide range of wavelengths, ranging from what we would typically describe using nanometers, which is 1/billionth of a meter, or micrometers, which is 1/millionth of a meter, all the way up to centimeters. We usually denote wavelength with the Greek letter lambda. Another characteristic that we can think of for radiation is the frequency. The frequency is the number of wave peaks that move past a certain point, given a certain time interval. We typically measure that in per seconds. So we can think of the frequency, or we denote this with the Greek letter nu, and the unit would be per seconds. Because electromagnetic radiation moves at the speed of light, we have a very natural relationship between the wavelength and the frequency, which is that the speed of light, c, is equal to the wavelength times the frequency. This is a very easy way to convert between wavelength and frequency. Other characteristics that we can think of is, for example, amplitude, which we can imagine as the vertical distance between the wave bottom and the wave peak. And this is a way to think of the intensity of the radiation. The last characteristics that we'll talk about right now is polarization. You can think of that as the orientation of the wave field. So for example, right now I've shown you a wave that moves up and down, but you could imagine that other waves might be moving in and out of the screen in a way that I can't show you now. So that's what we call polarization.